Today we'll finish up section 10.2 and we're going to start today with our Nissan Altima data. You should have this in from previous examples from this section. If not, feel free to pause the video for a minute until you get the information plugged back in. So what we're going to do is complete the coefficient and ANOVA tables for the Nissan Altima. We're going to start with the coefficient table. So what we're looking at is the regression analysis for age of the vehicle versus the price. So what we're going to do is in the spreadsheet, we want to go to linear regression t-test. The linear regression t-test will come up with most of the coefficients that we need, as well as the t-value and the p-value for the slope. So as I'm looking at the iPad, the constant, which is our intercept, will be value of A. And our slope is the value of B, which is negative 20.2613. So I'm going to build my regression equation first. So the price can be predicted by using the slope times the age plus the intercept. The intercept here, the 195.468, that is the coefficient for the constant. If you did not have the regression equation, we could use the existing standard error for the coefficient and the t-value to calculate it. To run a t-test, we take b sub 1 and we place it over the standard error of b sub 1. It would work the same for b sub 0, which is our intercept. So I have x over the standard error, and this equals the t-value. And by simple cross multiplying, you would come up with 195. So if the regression equation wasn't present, you would still be able to calculate this value. We're going to move on now to the slope. So pulling it either from the iPad or from the regression equation, we can see that the slope is negative 20.2613. This is the value of B. The standard error for the coefficient is listed as SE slope on your iPad. And then they also provided the T on the iPad as a negative 7.23. And the p-value, make sure you touch that cell so that you can see it. The p-value is actually so small that it's in scientific notation, and it is essentially 0. From the coefficients table, we could run t-tests to see if the slope is 0. Now we're going to look at our sources of variation, our ANOVA table. So again, we're dealing with the Nissan. The age of the vehicle is the explanatory variable, so that is the source for regression, which is 1 degree of freedom, 1 explanatory variable. For error, we had 11 observations. Error is going to be n minus 2 for degrees of freedom, so it'll be 9. And then the total degrees of freedom is 10, which is n minus 1. Based on the information I have, they provided the mean square for the regression. What I'm going to do is multiply 8285 times 1 to get the sum of the squares. And now that I know this value, what I'll do is I'll take my total sum of squares and I will subtract off the 8285 so that I can get the sum of squares for the error. Moving on from that, the mean square error, MSE, it'll be the 1423 divided by 9 degrees of freedom. And then to calculate the F statistic, we're going to do the mean square for the model divided by the mean square error. And my F statistic is pretty large, giving me a p-value of 0. And again, to get your p-value, it would be FCDF on the calculator under the wrench. And then going from there, they'll ask you some questions for you to input. Now, the last thing we're going to do on this ANOVA is to calculate S, our sample standard deviation. In a previous lesson, we said that if you know what the mean square error is, and in this case, it's 158.17, we're going to square root that value, and it will obtain our sample standard deviation. If you recall back in possibly section 10.1, maybe early on in section 10.2, we did calculate our sample standard deviation by hand. When you know the value of the mean square error, it's even simpler. When we make a scatter plot, we are typically looking for a linear relationship. In the past, we had used R for our correlation coefficient. As we move into inference, we're still going to use the correlation coefficient to measure how strong our linear relationship is and the direction, both positive or negative. When we work with inference, we don't technically know the value of R. So what we do is we use the Greek letter rho. It does look like a P, and this will represent R, our correlation coefficient. So really, if you were to test this, it would be very similar to testing beta 1. The slope is equal to 0. So we're just saying that the correlation coefficient is 0, which would imply that there's no linear relationship in the population. So if you were to test this, you would set up your null hypothesis that rho equals 0, and likely your alternative would be that rho is not 0. Notice it's a t value. So we need the correlation coefficient that will be an unbiased estimator for our sample. We're using n minus 2 square rooted in the numerator, and then 1 minus r squared in the denominator. So n will be our sample size, r is our correlation coefficient, and because it's t, we're going to use n minus 2 degrees of freedom. And then you'll be able to calculate the p-value using the calculator. So you can set it up as a one-sided or a two-sided test for rho. Remember, if it's two-sided, you'll want to multiply p by 2. We have 3 problems due for Friday. So this is 10.45. You're just going to complete the ANOVA table. 10.60, I am going to send this data to you in the email. If you prefer to put it in by hand, that's totally up to you. Here's the rest of 10.60, and then you're only going to do part A for 10.61. And this data is the same as 10.60. If you have any questions, please feel free to contact me and ask. Otherwise, I'll see you on Friday for our Zoom session to correct homework for 10. Have a great day.